Okay, hi folks, we're back for another walkthrough of a National 5 multiple choice paper, and this time it's the turn of the 2021 paper, which was actually written in 2020, but there were no exams that year. But then it was given to schools in 2021 so that they could use it as an in-house exam. It is available on the SQA website, and it's also on the Calder Glen High School National 5 Physics page. So if you go there and scroll down to National 5 SQA Past Papers, then if we look at the table, it's the one that says 2021 N5 Physics, and we're going to have a look at Paper 1. That's Section 1, the multiple choice questions. Notice at the top it says the 2021 Assessment Resource. Usually it's just got the year there, but this was a bit of a special paper. It's 2.5 hours. We're only going to look at Section 1, that's the 25 multiple choice questions. We're going to try and do that in about half an hour. First thing you see, as usual, is the data sheet. That contains the numbers that you might need as you work your way through the paper. And as usual, make sure you pause this, have a go at the questions first, and then come back when you're ready, and we will show you how we have done it. And so if you're ready, then off we go. The first 10 questions or so are from dynamics and space. So question 1 says, which of the following is a vector quantity? Well, you should know that a vector is a measurement that requires a magnitude, that's a size, and a direction for it to be fully described. And there are 5 vector quantities at National 5 Physics. They're there. Every other measurement we make is called a scalar, where just a single number describes it fully. So the answer we're looking for in this case is force, because all the other answers, distance, mass, time and energy, they are scalars. Okay, so that's question 1A. Question 2, a skydiver falling from an aircraft reaches terminal velocity because, well, let's do a little sketch here of a skydiver jumping out of an aeroplane. Now his weight is going to be acting downwards, and as he falls, air resistance is going to be acting on him, and eventually air resistance will balance his weight and he'll fall at a steady speed. So the answer we're looking for is the skydiver's weight is balanced by the air friction. That's 2D. Question 3, a block of mass 5 kilograms is placed on a smooth horizontal surface. 2 forces are applied to the block as shown, and we have to work out the acceleration of the block. So let's jump straight in here with our Newton's second law relationship, F equals ma, where F is the unbalanced force acting on the block. Let's rearrange it for acceleration, A equals F over m. Now the unbalanced force is going to be the 25 newtons minus the 15 newtons. It's the force one way minus the force the other way. Divided by the mass was 5 kilograms. If you do that in your calculator, you'll get 10 over 5, which is equal to 2 meters per second squared. And that corresponds to answer B. That's 3B. Question 4. A student designs an experiment to investigate the relationship between the extension of a spring and the magnitude of the force applied to it. And different masses are attached to the spring, and the length of the spring is recorded for each mass. And the relationship between F, that's the weight of the object on the spring, and Y, that's the extension of the spring, is given by the equation F equals KY. So if we hang a bigger weight on it, then we're going to get a bigger extension. And the K in this equation is called the spring constant of the spring. Now the length of the spring with no mass attached is 0.08 meters, and when a mass is attached to the spring, the length increases to 0.11 meters. So that spring has got longer, it has extended by 0.03 meters. And the spring constant is 12 newtons per meter. And we have to work out the magnitude of the force applied to the spring. So let's just put those two numbers into that relationship. The K is 12 and the extension was 0.03. And if you do that in your calculator, it gives you an answer of 0.36 newtons, and that corresponds to answer B. Okay, moving on. Question 5. An arrow is fired horizontally with a velocity of 60 meters per second, and the effects of air resistance on the arrow can be ignored. And we're asked which pair of graphs shows how the horizontal velocity and the vertical velocity of the arrow varies with time during the first second of its flight. Well, if there is no air resistance, or if air resistance is ignored, then the horizontal velocity is going to be constant, and vertically it's going to have a constant acceleration downwards due to gravity. So which pair of graphs are we looking for? We're looking for a graph firstly of the horizontal velocity that is a straight horizontal line, because the horizontal velocity isn't changing. And then the vertical velocity is going to increase. The acceleration downwards is going to be 9.8 meters per second squared. So if we're looking at it over 1 second, it's going to reach a velocity of just less than 10 meters per second after 1 second. So that corresponds to the two graphs for answer D. Okay, question 6. A satellite orbits the Earth at an altitude, that's a height, of 540 kilometers. And the graph shows how gravitational field strength varies with altitude. And so at a height of 540 kilometers, we can mark that on the graph. That corresponds to a gravitational field strength of 8.3 newtons per kilogram. Now, if the mass of a satellite is 78 kilograms, what would the weight of the satellite be at this altitude? Well, weight is mass times gravity. If the mass is 78 and gravity at that height is 8.3, then if you do that correctly on your calculator, you'll get 647.4 newtons. But we're going to round that to two significant figures, because all the numbers in the question are to two significant figures. So that corresponds to an answer of 650 newtons. That's answer C. Question 7. A student makes the following statements about geostationary satellites in orbit around the Earth. And then we've got 3 statements, and we have to decide which of these statements is or are correct. So statement 1, the orbital period of a geostationary satellite is 24 hours. That's correct, because that's the same time as it takes for the Earth to rotate once on its own axis. Statement 2, geostationary satellites remain above the same point on the Earth's surface. Yes, they do. That's what makes them geostationary. And statement 3, geostationary satellites orbit at different altitudes. No, they don't. They all orbit at exactly the same altitude of 36,000 kilometres. So statement 3 is incorrect. So it's 1 and 2 only. That's answer C. Question 8. A star is 2.4 times 10 to the 18 metres from Earth, and we have to work out what this distance is in light years. Well, let's work out what a light year is first. It's the distance that light travels in 1 year. So we can use the equation distance equals speed times time. We can put in the speed of light for the velocity, and the time would be the number of seconds in a year. So there's 365.25 days in a year, times 24 hours in a day, times 60 minutes in an hour, times 60 seconds in a minute. That gives us an answer of 9.47 times 10 to the 15 metres. That's the distance light travels in a year. So if that's 1 light year, then all we have to do is divide 2.4 times 10 to the 18 divided by 9.47 times 10 to the 15, and that will give us the distance in light years. And if you do that correctly on your calculator, it comes out as 253.43 blah 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 blah, but we're going to round it again to two significant figures. So it's 2.5 times 10 to the 2. It's quite tricky because all the answers are given in standard form there. But 250 is the same as 2.5 times 10 to the power of 2. So that's 8B. Question 9. Light from a star is split into a line spectrum of different colours, and the line spectrum from the star is shown, along with the line spectra of the elements calcium, helium, hydrogen and sodium. And we have to identify the elements present in this star. So all we're trying to do here is match up the lines in the line spectrum from the star with the lines in the individual elements. So these two lines in the star spectrum match up with sodium. So did these two lines as well. And then that middle line lines up with hydrogen, and so does that last line. And that's it. So it's only hydrogen and sodium. There's no helium, there's no calcium in that star. So hydrogen and sodium only, and that corresponds to answer C. That's 9C. That's all the dynamics and space questions, so now it's on to electricity. Question 10. A heating element is connected to a 12-volt supply, and the power rating of the heating element is 48 watts. And we've to work out the charge that passes through the heating element in 5 minutes. Well, the relationship to work out charge is Q equals I times T, but we don't know what the current is. We're not given the current in the question, but we can work out the current from the voltage and the power. We need one of our power equations here. We're going to use P equals IV, rearrange it, so I equals P over V. The power was 48, the voltage was 12, so the current must be 4 amps. We can then substitute that into the charge equation. So it'll be 4 times the time. Now the time is 5 minutes. Don't forget to change that into seconds. So 5 times 60 is 300, and 300 times 4 is 1,200 coulombs. And that corresponds to answer E. That's 10E. Question 11. An oscilloscope is used to test 3 different power supplies, and the diagrams represent the traces seen on the screen of the oscilloscope. Remember, an oscilloscope is just a device that gives you a picture of the magnitude of an electrical signal over a period of time. Now, we're asked which of these traces represents a DC signal. Well, DC signals are direct current. That means the signal isn't changing. Or, in other words, the voltage is constant, and both X and Z are horizontal straight lines, which shows you that those signals aren't changing over a period of time, whereas trace Y, which is a sine wave, is changing. It's alternating over a period of time. It's an AC signal. So X and Z are DC signals. That means the answer is 11D. Moving on then, question 12. The graph shows how the voltage varies with current for 3 resistors X, Y and Z. Now this graph has got voltage on the y-axis, current on the x-axis, and so the gradient of each line will be equal to the resistance of each resistor. And that's because the gradient is equal to the change in the y-axis over the change in the x-axis, which in this case is V over I, which is equal to R. So if we work out the gradient of each line, so for X, the gradient will be 4 over 2, which is 2 ohms. The gradient of the line Y will be 4 over 4, which is 1 ohm. And the gradient of the line Z will be 1 divided by 4, which is 0.25 ohms. And then we have to choose which of the following 3 statements is or are correct. So let's look at them one at a time. Statement 1, the resistance of resistor X is greater than that of resistors Y and Z. Well, that's correct. In statement 2, when the voltage across resistor Y is 2 volts, the current in the resistor is 2 amps. Well, we could read that straight from the graph, and that is correct. Or we could work out using Ohm's law, I equals V over R. When the voltage is 2 and the resistance was 1 ohm, which was the gradient in a line, then that gives us our current of 2 amps. So statement 2 is correct. And in statement 3, the resistance of resistor R is 0.25 ohms. Yes, it is. So all 3 statements are correct, and that means the answer is answer E. Moving on then, question 13. In which of the following circuits would the readings on the meters allow the resistance of R2 to be calculated? So remember, a voltmeter has to be placed in parallel with a component and an ammeter in series with a component. And it's R2 that we're interested in. So answer A looks good. We've got the voltmeter across R2 and the ammeter is reading the current in R2. But let's have a look at the other answers just in case. In answer B, the voltmeter's in the wrong place. It shouldn't be in series. In part C, the ammeter's in the wrong place. In part D, the ammeter is measuring the current to both resistors. And in answer E, the voltmeter and the ammeter have been connected incorrectly. So it's 13A. Question 14, moving on to properties of matter here. A heater is immersed in a substance and the heater is then switched on, and the graph shows how the temperature of the substance varies over a period of time. And we've to state which row in the table identifies the sections of the graph where the substance is changing from a solid to a liquid and from a liquid to a gas. Well, if we start from point P, then the substance is starting as a solid and then it's heated, and then at point Q it's starting to melt, changes to a liquid. Then from R to S it's a liquid that's heating up, then it evaporates between S and T, and then it heats up again from T to U. So where is it changing state? It's between Q and R and S and T. In other words, it's where the graph is flat, where there's no temperature change. There's no temperature change when there's a state change. So Q and R and S and T, that's answer B. Question 15. A sample of water is at a temperature of 100 degrees C. The sample absorbs 9 times 10 to the 4 joules of energy, and we have to work out the mass of water changed to steam at 100 degrees C. So we've got a liquid changing to a gas here, and we need the state change relationship EH equals ml, and because it's a vaporization state change, I'm putting a little subscript V there. And heat energy supplied was 9 times 10 to the 4, and that will be equal to the mass times the specific latent heat of vaporization of water. And for that we need to go back to the start of the paper to the data sheet. And the latent heat of vaporization of materials is in the bottom left hand table. And since it's water we're looking for, then it's the very bottom one in that table. And the number we're looking for is 22.6 times 10 to the 5 joules per kilogram. So let's pop that into the relationship and then rearrange it and work out what M is. That's the mass change to steam. It's 9 times 10 to the 4 divided by 22.6 times 10 to the 5. And if you do that correctly on your calculator, it gives you a rounded answer of 0.040 kilograms. And that corresponds to answer B. Okay, question 16. A solid rectangular block is placed on a flat, smooth table as shown, and the weight of the block is 28 newtons. We have to work out the pressure exerted on the table by the block. Well, straight to our relationship sheet. Pressure equals force over area, and the force acting on the table in this case is the weight of the block, and that's 28 newtons. And we can see the area of the block on the table in the diagram is 0.20 metres by 0.10 metres. If you do that correctly on your calculator, it gives you an answer of 1,400 newtons per square metre, or 1,400 pascals that should be, which corresponds to answer D, 16D. Question 17. A gas is contained inside a sealed syringe, and the volume of the gas in the syringe is decreased, so we're pushing the plunger in, and during this time the temperature is unchanged, so this change in volume causes the gas particles to, well, if they've got less space to move around, then they're going to hit the walls of the syringe more often. Let's have a look at the other answers. They're not going to move faster because we haven't heated them up, we haven't given them any energy, so their speed isn't going to change. They're not going to gain energy. They're just going to hit the walls more often because they've now got less space to move around. Question 18. A liquid is heated from 22 degrees C to 64 degrees C, and what is that temperature rise in Kelvin? Well, if we work out the temperature rise in degrees C, it's 64 minus 22, which is 42 degrees C. And you might be tempted here to add 273 to that, but no. What you should really do is change them both into Kelvin first and find the difference between them. So 64 degrees C in Kelvin is 337 Kelvin, and 22 degrees C in Kelvin is 295, and the difference between the two of them is 42 Kelvin. So the temperature rise in degrees C is the same as the temperature rise in Kelvin because the degrees are the same size. It was the temperature rise we were looking for. That's 18A. Question 19. On to waves now. 5 water waves pass a point in a time of 10 seconds. Which row in the table shows the frequency of the waves and the period of the waves? Well, we can use a couple of relationships here. Frequency is the number of waves divided by the time. That's 5 waves in a time of 10 seconds. That's 0.5 hertz. And then if we know the frequency, then the period is equal to 1 over the frequency. 1 divided by 0.5 is equal to 2 seconds. So which row in the table matches these two? 0.5 hertz and 2 seconds. That's answer A. Question 20. A ray of red light travels from air into a glass block. Which row in the table shows the effect, if any, on the wavelength and speed of the red light as it passes into the glass block? Well, when light goes from air into a more dense medium, its speed decreases and the waves bunch up. In other words, the wavelength decreases. So wavelength decreases and speed decreases. That's answer C. Moving on, question 21, still with waves. Which of the following diagrams shows the path of a ray of red light as it passes from air into a glass block? Well, the rule is here that when you go from air into glass, the ray bends towards the normal. So the angle in the glass is smaller than the angle in the air. And the only answer showing that correctly is answer C. Question 22. A uniform electric field exists between two oppositely charged parallel metal plates, and an alpha particle, a beta particle, and a gamma ray each pass between the metal plates, and they follow different paths as shown. And we've to identify which row in the table shows the types of radiation that follow paths X, Y, and Z. Well, let's remind ourselves first what alpha, beta, and gamma look like. Well, an alpha particle is 2 protons and 2 neutrons, and overall that's got a positive charge. A beta particle is a fast-moving electron, and a gamma ray is a burst of high-energy electromagnetic radiation, and it's uncharged. So our alpha particle is going to be attracted down to the negative plate, the beta particle is going to be attracted up to the positive plate, and the gamma ray is going to pass straight through. And then matching them up with the letters then, path X is going to be our beta particle, path Y is going to be the gamma ray, and path Z is our alpha particle. And then the only row with them all highlighted is row D, so that's 22D. Question 23. During ionization, an atom becomes a positive ion. Which of the following has been removed from the atom? Well, ionization is always about gain or loss of electrons. It's the electron, so that's 23A. Question 24. A Geiger-Müller tube connected to a counter is placed in front of a radioactive source, and the number of counts recorded in 1 minute is 3,890. And different shielding materials are now placed in turn between the source and the Geiger-Müller tube, and the number of counts per minute is recorded. So with no shielding material present, the number of counts is 3,890. And then when a sheet of paper is placed between the source and the Geiger-Müller tube, the number of counts per minute goes down to 2,110. So paper absorbs alpha radiation. And then we put in a centimetre of aluminium, and there's no change to the reading. And if there's no change, then that means there's no beta radiation. And then we put in 5 centimetres of lead, and the reading goes down to 365, so some gamma radiation is being absorbed. So the two types of radiation that are present in the source are alpha and gamma radiation only. That's answer D. Last question then, question 25. During radiation treatment, a patient's liver absorbs 90 microjoules of gamma radiation. The mass of the liver is 2 kilograms, and we have to work out the absorbed dose received by the liver. So straight to your relationship sheet. Absorbed dose is equal to the energy absorbed per unit mass, D equals E over M. The energy absorbed was 90 microjoules, that's 90 times 10 to the minus 6. Divided by the mass was 2 kilograms. And that gives you an answer of 45 times 10 to the minus 6 grays, that's 45 micrograys. That corresponds to answer A. That's it then. the paper that never was, the 2021 assessment resource. Some people call it the 2020 paper. And hopefully that's been helpful to you. Just remember, hard work beats talent. We'll see you in the next one.